The amount of charge in a certain length, in a certain surface area, or in a certain volume is what we call as charge density. And that is what we're going to talk about in this episode of Physics is Easy with Mr. Jesse. In this tutorial, we are going to describe linear charge density, surface charge density, and volume charge density. These are the equations for volume charge density, surface charge density, and linear charge density, and the meaning of these symbols will be discussed in the next video.
So you're probably familiar with density. Density is the mass divided by the volume. I can write density as a capital D, and then this would equal the mass m over the volume v. Now, you can also think of density as a little bit of mass over a little bit of volume. Because if I have a uniform object, the density of the whole object is going to be the same as the density of a little chunk of that object. And we're going to use this idea to solve problems in electricity and magnetism. So now I want to talk about charge density. First, I'm going to talk about linear charge density. And that's lambda, and that's going to be charge over length. Charge is Q, length is L. Or we could think of it as a little bit of charge over a little bit of length. The linear charge density has units of coulombs per meter, charge over a length. So if I have a line of charge of length A and total charge Q, lambda, the linear charge density, could be written as Q over A, or dQ over dL, a little bit of charge over a little bit of the length. Surface charge density works the same way. Sigma is surface charge density. Instead of Q over L, it's going to be Q over A, the area, or dQ over dA, a little bit of charge over a little bit of the area. Surface charge density has units of coulombs per meter squared, and if I had, say, a square surface where the square had a side of length L and total charge Q, then sigma could be Q over L squared or dQ over dA. Finally, I have volume charge density. So again, works the same way. Rho is going to be volume charge density, and that's Q over V now for volume, or dQ over dV, a little bit of charge over a little bit of the volume. And the volume charge density has units of coulombs per meter cubed. So imagine I have a sphere of radius r and total charge q. Then rho could be q over 4/3 pi r cubed. That's the volume of a sphere, which could also be dq over dv, a little bit of the charge over a little bit of the volume.
So here is a summary of charge density. We have volume charge density. The unit would be coulomb per meter square. So we have the symbol rho is equal to total charge divided by volume, where rho is charge density. Again, the unit for that is coulomb per meter cube. The unit of total charge is coulomb, and the unit of volume is meter cube. On the other hand, surface density charge, or surface charge density, which is a symbol of sigma, is equal to the total charge of the entire area divided by the total area. So we have the unit, that is coulomb per meter square, and the unit of total charge is coulomb, and the unit of area is meter square. Last but definitely not the least is linear charge density, wherein lambda is our charge density, Q is the charge of the total length, and L is the length. So again, the unit of linear charge density is just coulomb per meter. Our charge Q has the unit of C. Again, that is the charge of the total length, and L, so this one here is L, that is expressed in meters. And that concludes this tutorial. Once again, always remember, physics is easy with Mr. Jesse.